And we're live. Welcome back to another Corona Geek here where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever. And today we're talking about bungee jumping with vines and culturally accepted ear hoops that may not be a good idea 20 years from now. Or we could talk about shader math. I don't know. Which one do you guys think we should do?
I'm going to go with the shaders.
You're going to go with the shaders? All right. Joining us today is Ed Marina from roaminggamer.com. Also joining is Steven Johnson from GBulbaStudios.com. See how I
almost got it right that time.
I almost got it right. You know what? I'm going to kind of chalk that up to Google Hangout fuzz. So we're here with Studios and...
That's a good one.
Yeah, exactly. That's my excuse. I'm sticking to it. Hey, so do you guys have any announcements or anything you want to talk about before we get into the show? Before we jump?
Small announcement, and then I'm just going to shut up because I took over the whole show last time. I did finally start my Patreon. It's out there. Yay!
Awesome.
It's offering rewards that are not quite yet ready to go. I'm still working on finishing up the rewards, but they will be there for those who want to participate in the Patreon this month.
Oh, sweet. And you're going to send me a link to that, right?
I'm going to do that. I'll drop it in the thing, but I'll send you an email too.
Okay, yeah, we'll have full details on that. I think and let's talk about it on next Tuesday, or not, tomorrow. Tomorrow night at 6 p.m. Pacific, 8 p.m. Central, 9 p.m. Eastern. We are going to have our 5th Corona Geek After Dark hangout where we get together and just talk about app development, community insights, forum topics, general geekery is what I like to call it. So we'll talk about that then there because I know we definitely have been goading you, I think is a good word,
I think that's
about this whole Patreon thing. Yeah. Sweet.
Sergey's here.
Sergey's here. Can I add him to the broadcast? Hold on just a second.
Not pistachios.
There we go. Hey, Sergey. You're on mute, just FYI.
Hello.
Hello.
Hey, Sergey.
I was wondering why I'm black on the screen, and I thought this is a problem with my camera, but turns out this is a new feature of Hangouts.
Yeah, well, we've activated the cameraman feature so that we can add people to the broadcast as they come in. That way nobody can... do anything that they shouldn't be doing.
Pistachios.
Yeah. So, okay, well, cool. We'll have a link to that in the show notes then, and that'll be exciting to talk about. And so, Steven, what about you? You got anything going on?
Nothing new.
Nothing new? Same old, same old?
That's it.
And Sergey, got any news? Anything? Going to conferences? Releasing apps? Got anything to share?
I'm joining a startup for marketing and like coupons where people show their coupon on somewhere and they can use it somewhere else. And I'm working on the awesome plugins for Corona. It still takes a lot of time. I thought it would be faster.
Okay, cool. Just coupons for
pure or I can't think of the word.
Lua?
Native.
What? Oh, pure native.
What?
I'm sorry, Lua or native?
Plugins, native plugins.
Native? Oh, yeah, you're the man. See, you hurt my feelings.
I'm sorry.
No,
so
it just makes me feel small because I'm afraid of the native.
Are you, Sergey,
I'm also afraid.
Are you focusing on a particular platform like iOS or Android, or are you trying to make it cross-platform?
Plugins.
I know,
yeah,
but
plugins. So yeah, I'm targeting both platforms, iOS and Android.
So
there's one.
So you're having
one plugin would be only. Some plugins would be Android only because they don't make much sense on iOS, for example.
Right. Okay. Cool. Well, yeah. Let us know when they're. Well, we'll probably let everybody know, but I mean, give us when you've submitted. Let us know, and we'll talk more about it. All right. Well, let's get into 2D math because I know we have a lot to talk about, and I say we. So I know Steven has a lot to talk about. I'm going to listen intently. But I also wanted to ask, do you plan to cover anything on 2D shadows? Because I know that was a topic of discussion in the forums.
I I might, if I have time at the end, I guess, or I could
Okay.
do it right up front.
No, that's fine. That's fine. I don't want to, I was just curious. So just give everybody a kind of an insight as to what we're going to do. So they stick around if, which pieces they want. Okay, well, let's get into 2D math and talk about that aspect of things.
Okay, so in a previous show, I showed the little heat haze example where it was shimmering back and forth, and if you let it run for a while, it would start getting choppy. So I'm going to cover a little bit of that first, and then I'll go into just playing with some math equations after that.
So this is kind of an expansion of the topic of precision. I think we covered
Right.
touched on several times.
Yep.
Okay.
So if I and we see here on the reference card for OpenGLES that there's several precisions available.
Hold on. Is everybody seeing this desktop?
Are you
Not
seeing a
seeing your
PDF?
desktop.
Not
Seeing
seeing
your
it.
face still.
Say again?
We're still seeing your camera.
Oh, let's
Are
see.
you showing the desktop?
I didn't hit share. Okay.
There we go.
Okay. Now we see it, right?
Roger rabbit.
Yeah, but we see the hangout.
You still see the Hangout?
Okay, there it is. Sorry, go ahead. Got it.
Yeah, I think there's some kinks that need to be worked out of this process. So there's these precisions available in OpenGLES, high, medium, and low. And high might be available, or it might not, in the fragment shader. It will always be there in the vertex shader, but not necessarily in the fragment shader. And below that, there are some numbers with some terms that, if you'd just seen them, you might not know exactly what they're talking about. So relative 2 to the negative 16, relative to the negative 10, absolute to the negative 8. And what those are talking about involve the way numbers are represented in floating point. And they follow, are we seeing in this picture?
Seeing it.
Yeah.
Okay. So in floating point, under the hood it's a bunch of bits. There's a sign bit, there's some exponent bits, and there's some mantissa bits, or they're sometimes called significand bits. And a number is implemented as a sign, so positive or negative, times something 1 plus a fraction. And this could go from 0 to, in this case, 1023. And that corresponds to relative to the negative 10. To the negative 10 is 1 over 1024 times the next power of 2. So this will go from 0 to almost the next power of 2 over 1024 times the power of 2. And we go from the lowest implemented power 2, so in this case, to the negative 14, which is quite a small number, to 2 to the 14, which is 16 times 1024, so 16,384. And the thing about this is that as you go up in powers of 2, you still have 1024 elements between. And this is great when you're at very low numbers, like 1 to 2. There's 1024 values between those. That's pretty precise. So that you can probably land on the numbers you want. But as you get bigger, or larger, say you're between 2 to the 8th, so 256 and 512, suddenly spaces of 1,024th of that distance become 0.5. So you can only represent every 0.5 between those. And once you get between 1,024 and 2,048, suddenly you can only represent every 1, so every integer between those, and you have no fraction anymore. And so on all the way up. Now you start after this area, you'll start skipping 2 at a time and 4 at a time until you run out of numbers. So you can see that as you get higher and higher up in your number values, you'll start rounding to bigger and bigger larger and larger numbers, and you get choppy at that point, because even when you're interpolating between them, you're getting snapped to one integer or another.
So what do you do to compensate for that, I guess, is the question I'm thinking of.
Well, if you can scale the number back down, you can shrink it, by dividing by a large number, you might be able to mitigate the effects that way. So if you're multiplying by a small fraction, sometimes that'll be okay. If you're the one generating the numbers, then you might be able to break it apart and like apply the mod operator to shrink it before you multiply it out. But if the number is coming from somewhere else, like time, corona, which is just incrementing continuously, then suddenly you've got issues.
Okay.
And one way to avoid that would be to just pass in your own time value, but then you lose an input, and you only have 3 inputs left after that. And so if anybody has not seen those previous shows where I demonstrated the problem, I'll run a little demo for that.
Yeah. Give us a kind of an example of this, because conceptually I can understand what you're saying, but it would be good to see it in action.